than expected. Actually, there are never more than 25 forms, different forms, out of a theoretical 100. Okay, so to make it clear what I have tried to contribute, I have to say a word about automatic strength for conjugation. So this was my starting point. So Tolstoy divides the 400 something simple verbs into 6 intransitive classes and 8 transitive classes, according to their pattern of stem alternation. For each of those 14 classes, in each particular cell of the paradigm, they give a list of 4 figures, referring to the stem that is used respectively first in non-preterite affirmative, then in preterite affirmative, then in non-preterite negative, which, by the way, is redundant because it's always identical to the affirmative one, and lastly, in preterite negative. And those stems have to be looked for in the lexicon. So what I give you on the bottom left corner is a screenshot from Tolstoy's lexicon. So, for example, let's take the verb leima, to plant, to pour out. It belongs to the 5th transitive class, which Tolstoy calls VT5. So to every VT5 verb, 5 stems are associated. That's just a coincidence. The numbering of the conjugation doesn't always match the number of stems. For most VT5 verbs, those stems consist of respectively a first stem in T, a second stem in double T, a third stem ending with a glide. There is a 4th stem in nasal, though it is debatable if the N is really part of the radical. And there is a 5th stem, in ending in the long vowel. But that's not the only possible pattern in this class. In fact, most verb classes in Tolstoy's grammar mix up verbs of various patterns. But to make it visually sexier, I try to split Tolstoy's table into 3 tables, one for each tense. And remember that all verbs have the same alternation pattern in non-preterite affirmative and negative, so that makes only 3 subtables and not 4. And then I have added color coding to make it easier to see which stem is used in which cells. So these 3 tables combined give the exact same information as the one in the preceding slide. Remember, in a more readable way, I hope. And for each stem space, that is for each color, I provide an example of verb form below. 2 remarks are in order. First, as you can see, the allomorphy of the radical is not conditioned by the phonology of the first suffix that is attached to it, at least in synchrony. If you take a look at forms 1 and 2, for example, there's no reason why the final T should terminate before the suffix in one case and not in the other. And second remark, and there you have to take my word because I couldn't show all the conjugations on the slide, but the distribution of stems ending in a stop and stems ending in a sonorant, so nasals, liquids, glides, this distribution can be generalized across consonant verb classes, across all classes actually. So it's not only that class which present this dichotomy. But I will get back to it at the end of the talk. So after these opening remarks, I can finally expose what my work was meant to arrive at. The goal of the internal reconstruction is to unify the range of stems that each verb exhibits. The whole procedure relies on the assumption that historically a single form has given rise to the variety of forms that we observe today, depending on the phonological context it was in. And that single form that we assume to be the root must provide all the information needed to uniquely identify the verb. That is, 2 different verbs, as long as they are not homonymous, cannot have the same root. This root is not necessarily one of the stems that are in existence in the paradigm today. The reconstructed root is not only supposed to account for the history of the language, it's also meant to reach economy of description and to allow for comparison with the other current languages. So in the table below, I give a few examples that show that no actual surface form suffices to unambiguously identify a verb. The color fields here are nothing to do with the colors I used in the former slide. I only wanted to show which cells were identical. So Tolstoy uses the infinitive as a quotation form, but this choice is rather unfelicitous so to speak, since the infinitive is one of the least informative forms in Kulung. In consonant verbs, the non-preterite 3s to 3s form may help disambiguate verbs with identical infinitives, as in the case of doima, which makes doia when it means he sets fire to it, it's in the second column, as opposed to datta when it means he learns it. As for vocalic verbs, conversely, the infinitive is less ambiguous than the non-preterite 3 to 3, as you can see in the last three columns, bama, sama, boma. But you also see that the inflections of soima, so soima to tease and doma to set fire to, while they are identical in the infinitive and the non-preterite, have to be distinguished on the basis of their past 1 to 2 form. So if you only know any two of these three cells, you can never know for sure how the verb will inflect in the third cell, which of course doesn't mean that Kulung verbs all have three principal parts. It only means that if Kulung verbs are to be labeled by a unique form, then this unique form cannot be any of the actual surface forms. So we have to reconstruct it. Okay, now I will move on to explaining what I did exactly and in what order I did it. First, I have not stressed that enough, but Tolsma's grammar is unfortunately riddled with misprints and inconsistencies from one page to another, which makes it very difficult to use. So I had no other choice than checking every single dubious piece of information in Tolsma's grammar against the New Testament corpus, whenever that was possible, because the New Testament obviously doesn't contain every form. And this was really the bulk of my work on Kulung. Only once that was done, I could sort all the verbs according to their inflection pattern. In most cases, the inflection pattern is nothing more than the alternation pattern of the final consonant of the radical, but there are also some verbs where the radical vowel undergoes apophony, so the whole rhyme has to be taken into account. Then, to each of these inflection classes, a unique root form is assigned, knowing that the shape of a reconstructed root is constrained by what we know of Proto-Kiranti syllable. And okay, I will say more on that later. And I also take comparative data from other Kiranti languages into account at this stage. And finally, I sum up the realizational rules that describe how the various stems in each inflection class are derived from the underlying root. Okay, I think there is no need to dwell too long on that. So various kinds of shortcomings in Tolsma, but to give you only one example to show you how I worked, there is an obvious gap in the paradigm of the verb mama, which means to do, because all the forms with a first person or second person object are lacking. And of course, we don't say I do, you, they did, me, etc. But the verb to do is very frequently inflected in these configurations because it can be used as a verbalizer or light verb. So it can transform almost any noun into a transitive verb. I give you an example with the verb to create, which is translated in Kulung as banei mama, literally to do creation. And by the way, I think banei is borrowed from Nepali. So in order to find a verse in the Bible that's likely to provide me with the verb form that will fill the gap, I search in both ways, from Kulung and from English. So I look for an English verse that contains the personal pronouns I want in the syntactic function I want. In this case, I was looking for a second person singular subject, so thou, and in early modern English, thou, and a first person singular object, so me. Besides, I also query the Kulung text in search of the form that I postulated to be the one I was looking for. In this particular case of the preterite 2 to 1 for the verb to do, I had good reasons to believe, by comparison with other vocalic verbs, I had good reasons to believe that if the form existed, it should be more. And actually, it turned out to be exactly that. And apart from gaps or errors regarding stems, there is also a number of problems regarding affixes in Tolsma's paradigms, but I won't go into the details. Suffice to say that I checked in the same way I have just described for stems. Okay, so once the data has been verified, the rest is almost a piece of cake. As I said earlier, within each of the big classes as defined by Posma, so what we could call macro classes, we can make finer grained distinctions according to the rhyme patterns, which here I call microclasses. So each line represents a distinct microclass and indicates the list of its alternating stems. So here capital C stands for any consonant or 0, capital V for any vowel. And I'm only showing you a sample because, of course, there are more classes than that. There are also vocalic transitive classes and intransitive classes. In some classes, the vowel alternates with the vowel o, but never with another vowel, which points to a common origin. And well, the historical development of this ablaut or apophony has yet to be clarified, but we can take it for granted that the vowels were originally 5 in number, which is well known from the internal reconstruction of other Kiranti languages. Also, roots with an O vowel and a velar final consonant, so a K or a N, those roots are peculiar in that in some verbs the vowel O alternates with A, and in others it doesn't alternate. I have not been able yet to disambiguate verbs in ong, but verbs in ok can be very easily disambiguated, considering that the rhymed class ak doesn't exist in Kulung, which suggests that all the verbs with non-ablauting ok must descend from original ak. Okay, so this is supported by external comparison with cognate verbs as well. I have mainly used data from Bantawa, Kraling, Wombule, and Limbu also. And out of around 450 Kulung verbs, I could find at least one cognate for around 300 Kulung verbs, most of which were in Kraling. Okay, we also know that Proto-Kiranti had syllable endings Proto-Kiranti had syllables which ended with complex codas, the first element of which is called the final consonant, and whose inventory was very limited. And the second element of which, the second element of the coda, is called the post-final. And that post-final could be either S or T. Today, Kulung still possesses syllables with post-final S, but not with post-final T. But we can assume, nonetheless, that the radicals where the final consonant shows gemination in some paradigm cells descend from roots with post-final T. And this assumption is grounded in many cases in external data as well, just like the issue I've just mentioned regarding the ok or ak verbs. Okay.
You have 4 minutes. Yeah, you have 4 minutes. Yeah.
Great, thank you. So I'm approaching from conclusion now. I only sum up the general rules that are valid across microclasses. And so those rules basically sum up the preceding slide. So I only show the rules that apply to consonant roots, but vocalic roots also have their rules, even if they are a bit more complicated. So these rules are very simple. Overall, consonant verbs tend to have 2 stems, or 2 families of stems, a strong one and a weak one. The roots ending in a glide or a liquid do not show allomorphy. Roots in long high vowel shorten this vowel in the weak stem. Roots in S lose the S. Roots in velar consonant turn that consonant into compensatory lengthening. Roots in labial consonant lenited to M, and roots in dental consonant lenited to a glide. And there are also special rules for roots with postfinals and for roots in ok, as I mentioned. Okay. Before concluding, it's worth pointing out that although they behave very differently, consonant roots, here corresponding to the 3 diagrams in the upper row, and vocalic roots, so in the lower row, follow roughly the same pattern in the sense that the paradigm can be divided into two broad stem spaces that I have colored here in shades of blue and shades of orange. Okay, so consonant roots remain mostly intact in the blue domain, while they are lenited in the red domain, or the orange domain, depending on how you see it. As for vocalic roots, it's the opposite. The root vowel remains mostly intact in the red domain, while it's sort of disrupted in a variety of ways in the blue domain. And this seems to suggest, even if it's less clear in Kulung than in other Kiranti languages, but in the blue domain, the first suffix was originally a vowel, or began with a vowel, which is why coda consonants were preserved through resyllabification, while in open syllables, root vowels blended with the suffix vowels. And conversely, in the orange domain, the first suffix may have begun with a consonant, which would explain that in closed syllable coda is lenited, while in open syllables, root vowels were preserved. So to sum up, I have tried to show that Kulung conjugation is somewhat simpler than Tosma makes it look, and I hope you are convinced of that as well. My reconstructions are very similar to those already arrived at by other scholars working in closely related sister languages, and Kulung displays the same dichotomy as in these languages between pre-consonantal, originally pre-consonantal stems and originally pre-vocalic stems. But further research is needed to explain the ambiguity of some roots, mainly roots ending in ng. I also need to explain why some roots with the final k lose that k everywhere, but before the suffix, the dual suffix tsi, and the historical grammar of the language remains to be written also. Thank you for your attention.
Thank you, Jin. Now I'd like